everyone, welcome back to my channel, and today my topic is about electricity and magnetism. My research came from the Google Encyclopedia shown to my left. Electricity is the positive and negative charges attracting each other, forming a spark of energy. Some examples include a nylon comb touching against hair. When you comb your hair, sometimes your comb gets attracted. Like my hair gets attracted when I comb my hair. This is because the nylon comb interacts with the hair. Another example is with the battery. A battery may have a positive charge and negative charge. These are often on the two ends of the battery. So when it is plugged into, for example, a clock, that allows the clock to work, and the positive and negative charges will slowly burn off. Lightning strikes are a common natural form of electricity. This happens when positive and negative charges vary too much in the clouds, causing it to explode in a burst of electricity. Friction is also one way to help electricity. If my hand was an object of positive charge and my other hand was an object of negative charge, when I rub them together, this causes the electrons to move. So now both hands have a range of positive and negative charges. Moving on, there are two main forms of electricity. There is a current electricity and static electricity. So what's the difference between the two? First, current electricity flows through objects. So all these examples involve wires or conductors flowing through to an object. These include telephone wires, turning on lights, and charging a phone. I charge my phone often, and I always have wondered how electricity got through. This is actually because of current electricity from a source powering my phone. Current electricity has equal amounts of positive and negative electrons, so that means it will power equally. But static electricity is a different story. If you've ever touched a metal doorknob and it shocked you, this is because all the electrons are building up on the doorknob. But when you go to touch it with an opposite charge, it results in a shock. So your hand might feel a sting. A balloon with a hair is also another example. When you rub a balloon against your hair will stick to the balloon. It's not just because the balloon is sticky. This is because the hair naturally will attract to negative charge, which is the balloon. Lightning is a form of static electricity because the lightning strike is building up in the clouds, and when it's all filled up, it explodes. Static electricity is when the amount of positive and negative electrons vary too much. So if there was a big number of positive electrons and a small number of negative electrons, this results in static electricity. Let's talk about electrostatic induction. This means the process of charging an object without touching it. So paper can be attracted to a comb, shown in this picture. While the paper has positive charge, the nylon comb senses negative charge. Since naturally these two charges will attract to each other, this means the paper will rise slowly due to the direction of the comb. How we measure this is with a gold leaf electroscope. A gold leaf electroscope is a machine where when you hover something over it without touching the machine, a thin gold film will rise up depending on how much charge there is. So if you continue to rub a balloon against your hair harder and harder, this means that the gold film will go up because there is more charge inside the object. Magnetism is the invisible force that attracts or repels certain materials. So, attractable materials include iron and steel. And I have a whiteboard that's magnetic. It's magnetic because there is a thin layer of steel underneath, so it makes it very handy to just attach objects to it, such as a dry erase board, marker, or a dry erase. I'm going to show you a video about magnetic domains. Magnetic domains are where objects or little tiny filaments will line together, creating a magnetic field. This is when people place a magnet on top of an iron filament board, and they all will attract in the direction of it, creating a magnetic field. Also, magnetic domains can be messed up. So, for example, when north poles and south poles attract, that this means that they will attract naturally because the magnetic domains will naturally attract to each other. But when, for example, north and north or south and south magnets will attract to each other and they try to, it won't work. This is an example of two magnets, and they cannot attract with each other because the magnetic domains are too spread apart. But when this person flips over to the North Pole, the magnetic domains attract. The modern use of electricity and magnetism vary in our everyday lives. As we get more advanced in our life, we will use magnetism and electricity more often. Electricity is now commonly used for indoor appliances like washing machines or utilities in the kitchen like blenders or a stove. We have also recently developed the electric car, which develops on a huge battery, and as a car runs, it will slowly burn off that electricity. The charging stations also look different because they don't look as bulky as a gas station because it is powered with electricity. That means you can think of it as charging a phone, but you have to charge a big object like a car. Magnetism is used for maglev trains and shark repellents. Maglev trains are when trains will use magnets to go along. This is much faster than normal wheels because the magnets create a force that the train can easily slide across. And while the magnet flips over, this causes the train to attract to the ground, causing it to a complete stop. Shark repellents are magnets that can be used from far away from nets, so sharks won't easily get past these, so sharks don't have to enter a certain area. And last, they are used for magnetic resonance imaging. This is sort of like a CT scan. When a body enters through the scanner, it uses magnetism when radio waves attract to an image and create an overall image of a part, like a spine. In conclusion, I think that magnetism and electricity will help us a lot in our everyday lives. I have to use electricity to send this video over to you, whether it's with wireless electricity or with wires. Thank you for listening. I hope you like and subscribe to my channel.